Okay, good afternoon, guys. Why it is very shiny. Okay, so I'm Chang-Ho Choi. I'm a senior principal engineer in Samsung. Okay, George presented event management agent stuff, but let me switch our gears a little bit different way. I will propose out-of-band device management control, but this is complementary of event management agent. It is not exclusive. Okay, let me start with background, the out-of-band management. As you see in the lower diagram, there is two main paths to the device from the internet. You could, in the top, oops. Anyway, so in the top part, actually, there is a in-band. Most data flows in-band network, like a service network and main switch, and then data goes to server. And host server, they have a CPU and also BMC. And host connect to the device, such as SSD, through the processing unit. So with this in-band path, we generally collect telemetry data that include some failure analysis information or critical sensor or device status information. In addition to that, we have a management path. So nowadays, we use out-of-band network. As you see here, there is a remote administrator agent that connects to management switch that is excluded from data path. And management switch connects servers in a rack, and the server connects to the device through the BMC. BMC is a board management control. So BMC collects some server-related information such as temperature, and also fan or power supply units. In addition to that, BMC collect device information. Such as SSD, we provide EEPROM for some out-of-band management information. Current EEPROM stores device critical information, such as device vendor information and device serial numbers. As I said, many telemetry information is collected through the in-band network. What if device processing unit crashes? For example, firmware crashes somehow and device goes to abnormal state. In that case, we cannot collect very important information for such as device status and failure analysis information and failure prediction informations. As I said, device provide some information through the EEPROM, but the EEPROM size is very small. They could host very limited information, such as vendor product data, that vital vendor product data itself. So to overcome this kind of limitation, we developed a device management control architecture that is our current proposal. The key idea is that instead of store some data in small EEPROM, we wanted to replace that one with a management control unit. Management control unit connected to processing unit, still the management agent could collect device telemetry data or some failure-related information through the processing unit, through the in-band network. But as I briefly described in the previous slide, when processing unit crashes, in that case, we will lose the information. To overcome that kind of a situation, the management control unit snapshotting of the device critical information such as failure prediction or failure debugging information. So even processing unit crashes, management agent could still collect and retrieve information. With those information, we could run failure analysis, and also we could take some actions as needed very promptly. Okay, this is a very high level, and we wanted to define some the data structure or data model between BMC and management control unit, and also we wanted to define some protocols that interact with without any interruption. Okay. Now the BJ will discuss some requirement and our POC stuff.
Thank you, Chang. This is BJ from Samsung, and I'm in charge of this DMC project. I'd like to today about the hardware requirements for DMC and dataset and protocol between BMC and management unit in storage device. As for hardware requirements, the first thing is in any situations, BMC should be able to check the status of the device. For this, a separate management control unit is required. And this MCU must be directly connected to the BMC via out-of-band interface. The second thing is MCU should be directly connected to the sensors in all kinds of sensors in the device, such as temperature, voltage, and current, and so on. The third thing, this is a different point from general PCI device. You know, SSD has more than 100 telemetry data sets. With this data, we can predict the device failure or predict device lifetime and debug failures. For example, you know, WAF, NAND read-write ratio and history, and uncorrectable error counts or correctable error counts for internal memory, like SRAM, DRAM, NAND. For this, both the processing unit and the management unit should be able to deliver telemetry data to the BMC via OB interface. For this, the processing unit should be able to log telemetry data to the management unit against device failures. And other items, maybe these are future features that MCU obtains system information through BMC and preemptively respond to system errors and update SSD firmwares. We are working closely with our partner company, Inspur, to specify the architecture we aforementioned. We are using open source software and hardware like OpenBMC and DCSCM module in the jointly developed Poseidon system. And we are working together to find ways for better out-of-band management of storage device. However, what we learned is that dataset and protocol should be defined first in industry. You know, I mean, standardization is required. Yes, there are already PLDM and NCSI and several NVMe spec. These protocols are well defined within DMTF. However, it provides limited function. So as a way of efficiently delivering the aforementioned features, which protocol is appropriate and how to improve it, these discussion items should be discussed. soon. So we hope to discuss this agenda together in OCP, and we will actively participate in management work group in OCP, OpenBMC, and DMTF. Yes.
Okay, thank you, BJ. Okay. As BJ mentioned that we collaborate with Inspur server company, and we demo on our demo of our implementation in global summit. So you could visit our booth like B14 tomorrow. Then you could see our DMC POC implementation. Last but not least, okay. As we discussed, we wanted to collaborate with industry. We wanted to define data set and features and data models together for effective out-of-band device management control architecture. In addition to that, we want to define protocols also. Once this one is standardized in OCP or in other standard group as needed, we could make a unified some device control architecture and systems. This work is also related to other standard group activities, such as OCP hardware management project and OpenBMC and DMTF. So Samsung is very open to contribute to OpenBMC and DMTF work also to enable these things with industry together. Okay, thank you for your attention.
Thank you. You want to take some questions?
Yes, any questions?
Quick question regarding the telemetry data. Since these devices will be serviceable, is there any consideration given to save this data on non-volatile storage to get back the state of information of what failure happened?
Your question is that even device fails, or
Yes.
normal cases, that is stored in the memory, and also it is persistent in the NAND device.
All right.
So, but if you say that even for device crash situation, yes, that's what I said. But it might not be real-time data.
Right.
Because as I said, yes, we could snapshotting telemetry data in real time, but as you know, it is not that effective in the device point of view. So we'll do snapshot of telemetry data periodically. Then you could get some data that is close to the device crashes.
Right. Yeah. All right. Thanks.
Thank you. That's a very good presentation. I didn't understand. You showed this little black box. And so could you please help me understand, are you proposing an additional hardware piece?
By the way, just give me 1 second. Could you make this one for? Okay, this. You mean the management control unit or something else?
Right. I think in your requirement discussion about the Inspur, you showed this black box. Yeah, right there.
This one? Yeah.
So are you proposing to add this hardware component in a data center on
No.
the machine?
This one is our SSD. This is our SSD. We implemented DMC in this device.
Okay.
There is no extra hardware. Well, it depends on actually, from the user's point of view, there is no extra hardware required.
I see. So this will be stored into the EEPROM that already exists today.
Now, that is the current situation, but we proposed that we wanted to include a management control unit inside the device, and we will add some extra storage for maintaining some more useful information.
So that's a new hardware then. The MCU plus the storage.
The MCU, that is, we provide. So users, they don't have to worry about that.
Okay, so if I am a data center designer, then I will have to buy this MCU with
No.
storage.
No, actually, as you know, you need to buy storage device. That is SSD.
Okay,
When you buy SSD, if that SSD is enabled the management control unit is inside the SSD already.
I see. Okay.
So let me rephrase it, right? What we want to see is all the I/O devices have this capability kind of things where you can have the runtime communication with either a sideband, either a rate face or the SMS or MCTP. We need to finalize that thing, right? We need to have runtime interface available so that you can able to query and get the data. Even the system is failing, the CPU is failing, you have a mechanism to talk to the I/O device, you will get able to get more data, right?
And
That's work we want to do and standardize it. We have not standardized. There's a prototype available. As a group, we need to agree on what we want to accomplish there.
so this will require a change in each of the PCI device then to add this MCU?
Either you might already have a controller today, or you may not have it. If you don't have it, it's a change. But it's for more new devices, right?
Gotcha.
In a data center, you need to deal with both the existing and the new one.
Okay, all right, thank you.
Quick question.
Okay, thank you, Sammy, for the clarification.
Quick question. So for querying simple variables like voltage, which never don't change, you can just poll any frequency. But for things like power data, which is time series, it's very different. You have to have sampling at intervals, and you have to low pass filter the data and the source. I'm wondering how you handle that situation.
Could you answer it?
What's the question? Could you?
There is two different data types.
Yeah.
One is the time series data, the other one is time
Yeah.
series data we need to sample.
Yeah. Maybe MCU get directly getting the sensor data, so it will be delivered to BMC in real time. But telemetry data will be logged in the MCU's internal memory. Maybe the frequency or the time has to be defined.
Yeah, that'll be the interesting question, how you figure out the standards to do that, because that should be standardized.
That should be, yes. That is a kind of data model also.
Thank you.
Thank you.
So I have a follow. Thank you. So I have a follow-up question to the previous question. Is this about standardizing the DMC protocol, or is it DMC as well as a management control unit?
DMC, actually, we wanted to define DMC protocol means how we could retrieve the information and then how we could define data models. So those things we wanted to define. Even though, as I said, we implemented it as a POC, but as you know, we need to get an industry agreement for the format or protocols. So I wanted industry work together to define it.
So the protocol is to be standardized, but what receives it on the other end doesn't have to be standard. Right?
Yeah, at least you need to have a baseline, the framework, what is the minimum each device or device class need to provide. But you could have still proprietary on top of that, right?
Yeah, in that context, actually, a framework. We could define framework.
I need more. I explain more explanation. In most PCI device, in case of that, they focused on the sensor data only. So maybe network device or FPGA device is already using the microcontroller for monitoring sensors. But in case of SSD, there are lots of telemetry data. So we have to deliver these kinds of data with out-of-band interface if SSD fails. We need standardization for delivering these kinds of telemetry data. Okay, that's it.
Okay, great. Thank you.
Thank you for your attention.